lot to show you, so let's get at it.
Dang it.
Factor. Special products. Now, I can show you real fast and be done with it, but I think what I want to do is kind of give you a little more lengthy explanation so that you're confident when I turn you loose, okay? So, first of all, you have your special case formulas to put these together that you're all supposed to have memorized. So what does that equal? Yeah, difference of squares. Okay? So now, given that, you need to do it backwards. Alright, so given this, you need to understand that that factors into a minus b, a plus b. And again, it could be a plus b, a minus b. So you're doing this stuff backwards. Alright, so example 1, let's do this real quickly. X minus 2, x plus 2. So everybody knows what that equals, right?
Yes.
Alright, so I'll wait till everybody catches up. Alright, so I'm going to work this out to show you. So that's x squared, that's positive 2x, that's negative 2x, that's minus 4. So that's x squared minus 4. 2x and the negative 2x cancel, right? Okay. Now when you see this, you need to understand that this is the difference of two perfect squared numbers or letters or combination. And then you ought to be able to factor into those two things. How do you do that? What are you doing in your brain to get the answers over here?
The square root.
Square root of both of those. Okay? So, when you see this, then you ought to be able to tell me that that's x minus 2, x plus 2, without any problem. Anybody struggling with that?
Is that the whole list?
No. Then how many special case formulas are there? Okay. So, let's see, let's go on here. I want to do the next one. Let's do example 2, the a plus b squared. If you remember, that was a squared plus 2ab plus b squared, right? When you put them together. Now, when you have this, you got to be able to work it backwards to factor it. Okay? So let's do one here. X plus 3 times x plus 3. We're going to put it together. That's x plus 3 squared. Everybody put it together and tell me what you get. Yeah.
X squared plus x. Wait, no. 2x to 3, which would be not 6x.
Thank you.
And then
B did 2 times. That's A, that's B. AB is 3x times 2 gives you 6x.
yeah, and then you add,
Or you do this, do the same thing, okay?
and then plus 2.
Alright, so he used the formula. Again, some of you are probably just as fast not to use the formula, but you need to know that there's a formula, alright? Now, given this, let's talk through this, working it backwards. Given this, you got to be able to identify if it's a special case formula. Well, the first term has to be a perfect square. The third term has to be a perfect square. And the square roots of those multiplied together, 3x times 2 has to equal that. If it does, then you can take the square roots of the first and third and just write them down. X plus 3 quantity squared.
Will there be some where we can't do it?
I'll get to that. Got it? Yes or no? If these aren't perfect squares, then you got to do something else. Let's look at example 3, which is the other one. A minus b times a minus b. That's a squared minus 2ab plus b squared. Just to jar your memory. So let's use x minus 4 times x minus 4. Everybody calculate that. You can use the formula or you can multiply it out, it's up to you. But for the test, you might want to make sure you understand the formulas. I don't remember looking at the test, but you're still expected to know the formulas, okay? Yes?
X squared minus 8x plus 16.
Good. That's a perfect square. That's a perfect square. The square roots of those for x times 2 is 8x. Okay? The other part to this is make sure that the signs are in the right place. Good. Now I just gave you something else you had to think of. Perfect square, the square roots times 2 have to equal this, and the signs have to be right. A lot of stuff to remember, right? Just to recognize if it matches the formula. Yeah.
What's the square root of x cubed?
X squared times the square root of x.
Huh?
That's in chapter 10, you're going to get that. I'll teach you how to do it. It's very, very, very simple.
Okay.
So, let's see here. What do you think of this so far? Great.
It's a lot like the other one you had to guess, but this is more like that, I guess.
What if I gave you this trinomial and said factor it before today? Could you have done it?
Would it take?
What? This is a 1 here. Remember the day we did it, the trinomials that had a 1 here? And all you have to do is have factors of that added up to this.
Oh, so it's the same thing.
Yeah. It's still a trinomial asking to be factored, right?
Can we use the other way then?
I remember that.
Okay, so let me ask you again. What do you think of this process versus just factoring it?
I like this one better.
Okay, that's fine.
I like that.
That's totally okay. So here's my point behind this. I got some other examples I want to give to you here just to make sure we cover our bases. But given the trinomial, that's what you're given today, or a version of it. If you can factor it faster the other way, just by factoring it, that's what I expect you to do. If you want to use the formulas, go ahead. Now, this better be self-explanatory. There is no factoring this. You just do what it says to do, right? Take the square roots of the numbers and put it into the formula. Right? The difference of 2 squares. That you just have to have memorized, but it's the only one that looks like this. It's not a trinomial. So if it's not a trinomial, it's probably a difference of 2 squares. Okay? So let's do some other examples here. Example 4. I'll let you choose what you want to do. Now, this is different. 81x squared minus 4. What is that? What do you think it is at first? Just by first glance. Yeah.
9x minus 2 times.
No, I didn't want the answer. I mean, what does it look like?
A
You're right. The difference of 2 squares. Are they both perfect squares?
Yes.
Okay. So, since that's a perfect square, what's the square root of that?
9.
9x. The square root of that is 2. So one's a minus and one's a plus. Doesn't matter which one's first. There you go. You just factored that problem. Can you factor it again?
Yes. Wait, no.
Why not?
Yeah.
2 is not a perfect square.
Okay, so the reason I asked you that is just because you can do it once, don't stop. You need to check to see if you can do it again, especially when you get down for 2. You'll have multiple steps. You'll do it, you'll be like, oh, I know that. You'll get the problem wrong because you didn't finish it. Alright, so it's kind of like reducing. If you reduce a large number by 2, probably you're going to have to reduce it again, right? Okay, so it's the same type of thing. Just because you factored it once doesn't mean you don't have to factor it again. So, let's take a look at this one, example 5. Having said that, you've been warned. Are there perfect squares up there? Other than your variables?
No.
Remember, the variables are perfect squares, but the other numbers aren't perfect squares, so can't do anything, can't factor it. So having said that, here's your first lesson on factoring. The very first thing you should always do in every type of problem is look to see if you can simplify the problem at all by factoring something out of it. Can I factor anything out of those two terms?
Not.
How about a -3? What does that give me on the inside? What's that on the inside? If I factor out a -3, what's left? Remember, that means divide.
I don't know.
What is -3 divided by -3?
1.
Okay. So if I divided this by -3, what would my answer be?
X squared.
Okay. Oops. So if I divide this by -3, what do I get? Yes. What times 3 will give me an 8? It's a bigger number.
60.
16. -16 here. So I have a -16y squared there. Okay, now is the difference 2 squares?
Wait, why is it on this?
That's 48 divided by -3 gives me a -16. Instead of putting plus negative, change it to minus. Okay. So that's the difference of 2 perfect squares. Now you can factor it again. This is the second time we're factoring. So that's x minus 4y and x plus 4y.
So we just leave that -3 alone.
Yeah, it doesn't disappear. Don't drop it, guys.
Sits there.
The answer is the zeros. Well, I'm making the zeros with those variables. Okay, let's go with example 6. 49x squared plus 14x plus 1. So it's a trinomial. What are all your signs? So, everybody try to figure that out. Yes. Yes. Okay. So since this is a special case section, this is going to match the second example over there. A squared plus 2ab plus b squared. Is that a perfect square?
Yes.
Sure.
1's a perfect square. 1 times 1 is 1. So the square root of 1 is 1 squared is still 1. Okay. So you can use the formula or you can just factor it.
Oh, yeah.
I mean, you don't. 1 and 49 and 7 and 7, that's the possibilities here. The factors of 1 are going to go here. They're both pluses. And if it's a special case formula, then aren't these both going to have to be the same?
I don't understand.
Special case formula. Isn't a plus b squared the same as just a plus b times a plus b? The parentheses have to be the same. So if you're factoring it and you know it's a special case formula, you know both these have to be the same. So I'm not going to pick 49x and 1x to go here. Yes?
7.
Yeah, it has to be 7. Now, after today, I'm not going to tell you if it's a special case formula. So you either have to factor it in general, like what we've been doing, which is my advice to you anyway, or you have to identify if this is a special case formula.
I'm just gonna back.
Yeah, I mean, I'm trying to get you to do that because the more of this you do, the faster and better you're going to get at factoring. Okay? I do not use the special case, the last 2 special case formulas to factor because I'm so good at factoring trinomials. because I've spent the time to do it. Yes?
Couldn't you use that formula to find it?
Yes, you can. Here's what I would suggest if you're still struggling. I would say, define A and B. A is 49. Excuse me. What's A? Can somebody tell me? It's not 49. 7x. Thank you. And what's B? 1. Why is it the square roots of those? Because I'm not asking you for A squared. I'm asking you for A at the moment. All right? Because what's the formula have to be? The formula has to be A plus B quantity squared. The formula doesn't have squares in them. Right? So my answer is going to be 7x plus 1. If you can identify what your A and your B are. Now, if you do it this way, you must answer this question. Is 2 times A times B 14x? It is. Okay, that's the part you have to check. It's easy to tell what A and B are. Take the square root of the first and last terms. But you have to check 2AB. Once you do that and it matches, then all you have to do is put A and B in the formula. I mean, this takes too much time. It'd be easier if you just factor it. But if you're still struggling, that's what you got to do. I'm not going to do the one I have on here. I have a fraction one on here, so we'll do something different.
Do we have to do fractions? Yeah.
Yeah. Oh, example 7. We'll be done.
Fractions.
4x squared minus 12x equals -9. And you're going to have some problems like this. That's why I put it up here. So now you have to solve for x, meaning get the zeros. What's the problem with this number, with this problem? Great. Doesn't equal 0. To find the zeros or to solve, you need to get everything on one side of the equal sign. So we need to bring this back around. So it's 4x squared minus 12x plus 9 equals 0. Now, it's just a trinomial like you've been doing. Either factor it the way you've been doing it, or identify A and B. What's A?
4x. 2x.
A represents this first term, the square root of it. 2x. What's B? It represents the square root of that. What's 2AB?
12.
Is that 12x? Okay, don't worry about the signs. You're just matching the values. The minus sign's in the correct spot, the plus sign's in the correct spot, and we know it's all right. So it factors into two binomials that are exactly the same.
4x. Or 2x plus 3.
It's a minus.
Minus 3.
Remember, if it's a plus, like this one, they're all pluses inside. This one is a minus. I erased the problem that it was. So this is 2x minus 3, quantity squared. Hold on. Equals 0. Right?
Oh, crap.
So there's only one number, right? One answer. What's the answer? Is that what you're going to say?
Why is it minus?
Because the formula is this. A squared minus 2AB plus B squared equals, well, that's the formula, which equals A minus B quantity squared. Okay? That's what you learned when you put this together with this. Now you're identifying that's a plus, that's a minus, that's a plus, that's a minus. They're in the right positions. It's going to equal this. Otherwise, you have to factor using your brain, like what we've been doing up to today. Yes?
Although x is 3 halves.
Oh, the answer, yeah. So there's only one answer here because the parentheses are both the same. So the answer here is going to be x equals add 3 divided by 2, 3/2.
So you don't do anything like this?
Okay.
Next chapter. Well, you won't need to. It's the same thing. Watch. 2x minus 3. The square means there's 2 of them, right?
Yeah.
Okay, so what's x have to be to make this 0? Either 2x minus 3 equals 0, 0 product, or 2x minus 3 equals 0. Well, I just said the same thing. It's only going to be, you're going to get the same answer. Okay? All right. Any questions? Yeah, Brody.
Why do you do 3 divided by 2?
I can't hear you.
Why do you do 3 divided by 2?
This is, if I take, you understand the 0 product rule? So I take each individual parentheses and set it equal to 0. How do I solve this equation?
Add 3 divided by 2.
Yeah. Okay. Add 3 divided by 2. No other questions? All right, your assignment. Page 603, 4 to 44 evens and the mixture of new evens. Begin.